Hello, everyone. Assalamualaikum. Good afternoon. See you again on the chapter 7, part 2. I would like to continue the chapter 7, part 1 from the previous video. Okay, it is actually just a few slides before we finish on the chapter 7. On the part 1, I stopped at the frequency division. So if you are given 2, 3 flip-flops, then you know how to get the frequency from the flip-flop circuit. If you add two, if you have 2 flip-flops, so you're gonna to have as divided by 4. If you have 1 flip-flop, the frequency is divided by 2. So then you get the frequency number. So now we continue on the next slides on the binary counting. So from the flip-flop, we can do a counter circuit, binary counting sequence. If you have this kind of circuit, a JK flip-flop which is connected to both input J and K with a logic 1, J and K with a logic 1, and then you can have a counter. Okay, if you have this connection circuit, then this is the you can have the output QA and QB as a counter. So we learned about clock on the previous slide. In order to get the output, you need to have a clock. So in this case, this clock is NGT, negative triggered clock. And this one is also negative triggered clock. So you can get the output of flip-flop at the negative trigger clock. When there is a clock, and then your flip-flop will function as a flip-flop. If you don't have a negative trigger, then the output of flip-flop as remain as it is. Okay, so if you refer to the JK flip-flop, you have the input 1 1, then you get the output. So with this clock, 1 1 1 1 is a trigger, so you have the initial value 0. At this clock, negative NGT, negative output, negative clock, trigger, negative clock, and then it will, because you have one you have 1 1 1, so this is the output QA. So output QA triggered. If you look at this carefully, tengok ni betul-betul, tengok betul-betul circuit ni. This clock is only connected to flip-flop A. This clock, look at this. This clock is connected to output of J, which is QA. It's not connected to this clock. So this waveform clock is only for flip-flop A. So flip-flop B will wait. This clock will wait the output of QA. So QB will wait the output of QA. So do you see any clock here? No. So you just remain, no change. Okay. Next clock. Next clock is here. This clock is only for this flip-flop. Okay. So you have negative triggered here. So what is the input? JK11. 11, you refer to the truth table. 11 is a toggle. So you toggle become to 0. Okay, QB. QB is referred to the output of QA. So do you have any clock negative trigger clock? Yes, because this output QA become clock to the flip-flop B. So this is negative trigger, kan, turun ke bawah. So QB will see the input JK11, then you get the output toggle. That's why you see toggle. So on and so forth. If you look at this carefully, this output QA and QB becomes a counter. 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1, so on and so forth. Continuous. So 0, 1, 2, 3, 0, 1, 2, 3. So this is the combination, or this is the circuit. This is a circuit of flip-flop that can perform as a counter. This is counter. So we will learn this chapter counter in the next chapter 8, which is this continue this chapter 7. Okay, if you look at this flip-flop carefully, this is clock. Okay, this clock is connected to QA. This clock connected to QB. So you have 3 flip-flop: QA, QB, and QC. So this clock is independent. This clock is only for A, but clock for B is coming from this flip-flop. So same goes to the third flip-flop. So if you study details the timing diagram waveform, it seems like previous one. Clock for this clock for output QA is become clock to the QB, output QB become clock to the QC. If you plot all this the waveform, you will get this is a counter 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 0, 1, 1, 1, 1, and then return back to 0, 0, 0. So this is a counter, 3-bit counter. Okay. Next is a timer 555 timer. The pulse width is determined by R1 C1 and is approximately TW equals to 1.1 R1 C1. So this is the circuit of timer: VCC, VCC out, TH threshold, trigger, reset, dish, grounding, and you have a capacitor, you have resistor. So this is the example of a timer, circuit of timer 555. The trigger is a negative going pulse, TW equals to 1.1 R1 multiplied by RC. Determine the pulse width for the circuit shown, path width. So path width TW equals to 1.1 R1 C1. So R1 is 10 kilo ohm, C1 is 2.2 microfarad. So you get 24.2 millisecond the pulse width. The pulse width. So that's all chapter 7. We will continue to the chapter 8 after this. Thank you very much. See you again. Bye-bye.